Okay, guys, graphing systems, you treat each one of them individually, like you work with each of them individually, just like you've been doing, but the only difference is the graph is all in one same grid. That's it. And then one additional layer is going to be, we're going to have to find where they meet, like those points of intersections, which our calculator is going to do that. Do you remember second trace intersect? Second trace intersect, right? When we tried to find where a line crosses the parabola. We're going to use that, okay? I'm trying to scare you a little bit with this, but don't be scared, okay? This is kind of like some textbooks have this. They tell you the variables that are present. They give you the inequality right there. And then x is part of the real numbers, y is part of the real numbers. That is a fancy way of saying no restrictions. Okay, no restriction, anything goes. Decimals, fractions, negatives, positives, everything goes. Same here, the second inequality is right here. Okay, so I'll call this, sometimes I like to say inequality 1, inequality 2, and then go ahead and work with them somewhere else. If they're stacked like that, I will try to spread them out so you can work with them right underneath, okay? That's gonna be my goal for you. This just means no restrictions. Do you remember domain and range? Basically giving us a domain and range, which is just pick anything you want. It doesn't matter. We're not restricted, okay? So let's work with inequality 1 here. Inequality 1 right here. I'm just going to go 4x is greater than 6y plus 12. Just like before, I'll tell you to clean up, okay? Meaning I want it to look a certain way. So I'm going to go 4x, the 6y comes over, right? This is kind of how we want it. If you go to a different school, different teacher, that teacher may not ask you to do this, but over the years, I've found that this is the least amount, it causes the least amount of issues when you do it this way. That's all I'm saying, okay? Here, x-intercept, y-intercept, just like before. So I'm going to kind of speed through some of these steps. So if it's x-intercept you want, it's 4x is equal to 12. Divided by 4, x equal to 3, 3, 0. I used nice and round numbers for this example, but be prepared for decimals, negatives, all of that jazz. Okay. Negative 6y is equal to 12. Divide both by negative 6. Y is equal to negative 2, 0, negative 2. Boom. So it's if right now we're just thinking, hey, if we wanted to graph this one, we would do the same as before. Then I rewrite, and you're going to now realize why I'm asking you to rewrite. A, to find where to shade, or where the true region is. B, when you want to find the intersections, our calculators can only take an equation that's isolated, right? Where it's y and then a bunch of stuff on the right side. So that's why I'm also going to ask you to do it, okay? So we rewrite this guy. I'm going to start with the original, the cleaned up version. And I'm going to bring the 4x now over to the other side. So negative 6y. The 4x comes over negative. When you bring stuff over, a sign change must happen, okay? Or else you're messing with the equation or the inequality, okay? You're breaking the law, okay? Technically in math. When you get it here, we're going to have to divide by negative 6. If you divide by negative 6, what happens to the inequality symbol? It flips. Okay, I'm going to make sure you understand. Okay, it flips. Okay, so instead of that way, it's now pointing the other way to keep this a true inequality. Watch what I'm going to do. I'm not going to reduce the fraction. And you end up with a -2. Please tell yourself, solid or dashed, that's your choice. It's dashed, right? There's no equal sign under the inequality. True region. Soon I'm just going to use the letter T. I'm going to go D, and then T, and I'm going to go arrow. The true region is where if it's pointing this way. If y is less than, then the true region is below. But do you remember reverse shading? I talked about reverse shading. This is a tool we're going to use to figure out our solution region. I'm going to say shade above. I'm going to tell myself, because I'm doing reverse shading, I'm going to shade the opposite area of where the true region is. So we're going to shade away all the false points, the points we don't want. Okay, that's why we're doing this. Let's put this in our notes, reverse shading. It's a tool. I have never seen it in a textbook, but it makes life a lot easier. Now we're going to do the same thing with inequality number 2. So that's 3y is less than or equal to -2x plus 9. Negative and negative turns positive. Yeah. Okay, clean up. We're going to bring this 2x over. So it's 2x positive plus 3y is less than or equal to 9. Now I'm going to figure out my intercepts real quick. And if you do this enough, this should take you 2 minutes tops. Okay, we divide both by 2, x is equal to 4.5, 4.50. This is 3y is equal to 9. I know I'm going a little faster. There it is. If you can't keep up, at least write down the intercepts. Rewrite. Let's do the whole thing. 2x plus 3y is less than or equal to 9. I'm going to bring the 2x to the other side. But Mr. Dixon, you just brought it over to the left earlier. Yes, I once clean up. I put my x's and y's on one side, number on the other. And it's 3y is less than or equal to -2x plus 9. Divide both sides by 3. You're dividing by positive, guys. You don't need to flip anything. Okay, some students are like flip, 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 right? Maybe at McDonald's, right? If you're flipping burgers, that's what you do all day, but not here, okay? -2/3 x plus 3 positive. Now you tell yourself, this is a solid line. The true region is where? If it's less than, the true region is below. We're going to shade. Let's go capital on this one. Shade above. Circle that. That's the one we want to use for graphing purposes. And now we're going to wrap it up. I'm going to use my scale here. I'm going to create a scale. That's good enough. That tells everyone that you're using a scale of 1. Okay? Let's do inequality 1. This is 3, 0, 0, negative 2. Check real quick. Is the slope positive? It is positive. It makes sense that it's going to be going up from left to right. And look at the legend here. I said dashed. I'm going to shade above. So let's go ahead and do that. This is y is less than 4 over 6x minus 2. Don't shade yet though. Draw your lines, then shade. The next line, 4.5 is my x-intercept, 0, 3 is my y-intercept, right? I'm looking right at my numbers, and it makes sense because my slope is negative. So it makes sense that this is going to be dropping from left to right. It's a solid line. Solid line. Let's label it. I like to label at either end of the line, not in the middle somewhere, because you will realize that it gets quite busy when you're... Okay, now we shade. You've got your boundary lines, now we shade. The first line we shade above, right? So I'm going back to the dashed one here, and I'm shading above, lightly. Then you go to the other one, the solid line, and where are you shading there? Above as well. You've told yourself that, so now you're not guessing. You're not going to mix it up because you're now in the graphing mode. Okay? So just shade everything above that line. So now, this, the one that we haven't shaded, is true for both of these inequalities. So this is our ultimate solution region. Can you please try pages 31 to 32? Okay? To be continued. Thank you, guys.